right, now are going to be our first examples for this section. So let's do one that looks like this. So we want to evaluate over the region R the function x squared plus xy plus y squared with respect to two variables, where our region is given by y is between 0 and 1, and x is between 0 and 2. And so just to be clear, this right here is our f of xy. I have to fill in my r and pick my order of integration by myself. And so, this one's kind of a silly one to draw a picture of, but I want us to get in the habit of doing it anyhow. So there's my x, there's my y. Actually, let's even do it slanty because I won't often be able to do that. There's my x, there's my y, here's my z. My region takes y up to 1 and x up to 2. So it's this rectangle in the xy plane. Actually, let's not shade it in. R. And then my surface, z equal to f of xy, is some bendy thing. I don't know. And I'm just finding the height ever on the surface and adding it up in all dimensions. Let's draw my z up here so it won't interfere with the arrows I want to draw. So imagine that I knew what f of xy looked like. It's that thing. It's always moving upwards, so it should be kind of like a very steep bowl-ish thing in this quadrant. So my first problem is setting up R. For this one, order doesn't seem to matter. In future, more complicated problems, I'll want to see what my easiest A, B, C, and D are. But since they're all numbers, this is that first one I warned you about. Quote warned. It was like a good thing, but sometimes those things are constant and then it doesn't really matter. So I'm going to go ahead and say we'll do dx dy this time, because you wrote a lot of integrals dx in the past. Maybe it'll be nice to write one of those again. So my dx bounds always tell me going from left to right. Let's try like different colors maybe. So going from left to right, I fill in my x bounds. And the leftmost bound is x equals 0, and the rightmost bound, x equals 0 right there. And my rightmost bound is x equals 2 right there. So my lower bound for x is 0, and my upper bound for x is 2. I'll try to do this next one with dashy lines for if the colors are hard to tell apart. Okay, so now I'm going to think about my y's. And so I think about going up and down. And my lowermost bound down here is y equals 0. And my uppermost bound up here is y equals 2. Sorry, y equals 1. This whole process that I just did probably felt really unnecessary. You were like, well, they told me y is between 0 and 1. I should have just written 0 and 1. They told me x is between 0 and 2. I should have just written 0 and 2. But I wanted to draw these pictures kind of painstakingly because drawing these pictures is going to be the easiest way to do these more complicated ones. But if I just start doing it then, you'll be like, where did this come from? So that first part was probably a little bit painful for you. Maybe you saw this and just thought, I know I plug in all these numbers where they belong to the same variable and can move on. But now we have something where all of my numbers are filled in, all of my variables are filled in, and I can start evaluating this. roll back to when I told you our strategy for this is going to be to treat the outside variable like it's constant, just kind of ignore it for now. Integrate the inside variable until it goes away, and then the outside variable. So my outside variable is y. So I'm going to treat y constant. I'm going to ignore that part. I'm just going to look at integrate 0 to 2, x squared plus xy plus y squared dx, and I'm going to ignore dy. And then, let's take this integral. I'm integrating with respect to x, so I'm just going to treat y like it's a number. If it helps you, think about this as being x squared plus y is 2 times x plus 2 squared. Integrate it exactly like you normally would. X squared becomes 1/3 x cubed. X becomes 1/2 x squared times the constant that was already there. And constants get multiplied by x. And then I evaluate it from, 0 to 2. And I said I keep going until my first variable is gone. So I still have some x's here. I go ahead and plug in x equals 0 and 2. So I'll get 1/3 2 cubed plus 1/2 2 squared times y plus 2 times y squared minus a bunch of things that are 0. And in this step, you have to be careful. I'm integrating with respect to x, so I plug in my numbers only for x. I don't plug in any numbers for y. See, that y squared stayed where it was. That y stayed where it was. There wasn't one there. And so this is going to be, let's put it on the next page, equal to 0 to 1, 8/3. So 2 times 2 is 4 times 2 is 8/3 plus 1/2 times 4 times y plus 2y squared. All right, so we kept going until our first variable was gone. Our outside variable was y, our inside variable was x. Now x is gone, so we can finally integrate with the outside variable. So see, if you just look at this thing, everything's y. You have to integrate with respect to y. And it should be pretty straightforward. Constant numbers, you get a y. Y becomes 1/2 y squared. So I will not skip steps because this section is hard enough as it is. 1/2 times what I had before times y squared plus 1/3 2y cubed. Evaluated from 0 to 1. So I'm just going to clean up my numbers here for a second. I just simplified that 4/4 in the middle. And I plug in my y equals 1. And I subtract my y equals 0. So that's 10/3 plus 3/3. Nope, no skipping steps, I promised myself. So that's 13/3. And now it's a number. Y is gone. And just a note here, we could have also done integral from 0 to 2, integral from 0 to 1, our original function, x squared plus xy plus y squared. integrating with respect to y first and then with respect to x. And the answer would have been exactly the same. It's just I chose to do this order, but in future problems we'll do different orders too.